Good afternoon and welcome back to the CERIAS Symposium. I hope everybody enjoyed lunch. Our first speaker this afternoon is Mark Lepker. Mark is a proud Boilermaker graduate and a employee of the NSA. He is one of two SEALs, which I can never remember what the acronym means, but Purdue is the only university that has two NSA SEALs assigned to them, so we're proud of that. And Mark has been very instrumental and very much involved in CERIAS the last several years. And one of the things that he's been instrumental in is bringing and helping develop the INSuRE program here at CERIAS. So the program started as a very small project, and we thought at the end, if the students came with a good project, we might send one of them to the DC area to talk about their research. And it was such an overwhelming success from the very beginning that we ended up sending all of the student teams out to brief the NSA on their research that they had done. And the program, that was the beginning, and the program has grown since then. So we invited Mark back to talk about the program, its successes, things that he's learned from our students, and opportunities probably for others to be involved in the program as well. Mark, welcome back to campus.
Thank you very much, Jerry. Appreciate it. Joel. Thanks, Joel. Jerry's down here. Joel's here. It's a great honor to be here and to share the aspects of INSuRE with you and a little bit about how it got started. But the briefing you heard right before lunch is a direct result of the INSuRE project. That is one of our biggest successes. Another one came from the National Security Agency, has a program called Commercial Solutions for Classified. And as you would suspect, developing high-end cryptographic systems is a very long, tedious process. You heard about the formal methods. That takes a long time. So we can't keep up with industry. And so we depend on Cisco, Juniper, Intel, Microsoft, IBM, all the big ones, to create, working with us on how to develop secure systems. And so this whole program on commercial solutions for classified looks at taking various systems and putting them in line to create good boundaries for networks. So if you put a Juniper, a Cisco, and some other router, those aren't going to fail all at the same time, is the theory. INSuRE had a project where one of the students actually developed an application that helped prove that, and it was so successful, we brought him in as an intern, cleared him, gave him the classified data, have him redo it. He then prototyped it within NSA, and that is now shared at the classified level with many of our partners, and he, yes, will start working for NSA. So that is one of the aspects of INSuRE that we also use, is it's a great recruiting tool. I'd also like to acknowledge Melissa Dark, who's in the audience, if you could stand, Melissa. Melissa and I had a coffee at the Union and Starbucks back in 2012, and I'll talk a little bit about that in a minute. But if it wasn't for Melissa, yes. If it wasn't for Melissa, INSuRE would never have happened. John Springer, who's in the front row, is our current person working it, and one of our first graduates from it is Hans Vargas, who's up here in front. So a lot of opportunities to talk here. As a former Air Force officer like the General, I have been ingrained to give you points. Here are my points. We'll talk about those as we go along. One of the aspects of leveraging academia and why it's so important from a governmental standpoint, we don't have the cycles to study the science anymore. You can just imagine the cybersecurity threats that are out there that the National Security Agency is adjudicating, along with our partners, the INSuRE, the FBI, Department of State, Treasury. All of us are actively working on the threat that is currently available to us. There is just not enough manpower to think back about the science. So what happened that one afternoon in the Union is something I hope to also give you guys as a stopping point, especially the students and industry that are here, as well as academia. Never be afraid to continue to ask, well, what if? So Melissa and I were sitting and we were going, well, what if NSA would come in and work with the students on these problems? Because a lot of master's and PhD students have to do a project, right? Well, why pick something out of a textbook or something that they just thought of? why not work on problems that are relevant to national security that we can't get to? That was the genesis of INSuRE. Is we started out and we were able to sell it within the agency because we have interns that come into the agency all the time and we give them projects to do. So this was just a virtual internship in essence. And so NSA has published on nsa.gov, you can go to it today, and it's the top 10 challenges that NSA faces that we can't get to. That was the initial set of challenges that we gave to the students to pick from. And the important part is we linked it to an actual technical director at NSA, to where that technical director at NSA, who's working the current problems day to day, became a mentor to the student, while Melissa and her faculty taught the class on how to do research, because the class is about how to do research, which is a difficult thing on how to do research. How do you curate data when you're done? How do you properly store it? All those aspects of doing research. That's what the class is built for, but using problem sets that are real. And as you saw the two examples that you just heard about, those examples actually come behind the green door at NSA and we use those. We use that work. Students unfortunately don't get to see the attributes of that, but it does improve national security. The student and faculties, the learning the long-term research, I think passwords we did over how many semesters? Like 4 or 5 different semesters. We had projects on the strength of passwords. So it taught the students how to pass on research to the next class, and then NSA would offer different twists on how we wanted that to be looked at. The history, I have a bunch of little slides. I won't actually talk to them, but you can read them as I'm speaking. 2012 was the very first one. As you can see, we started out with just 5 students. Hans was one of those. And just one, well, we had 3 NSA technical directors involved. And as you can see, as we progress down through, continually increasing not only the universities, they have to be centers of academic excellence for research, of which Purdue was one of the first cadre in that. They have to be those centers, but then also additional labs. And I have a chart on that that lists all the laboratories and the other government agencies that also place their problems into the bucket for the students to choose. I'll just let you peruse through that. And then the current semester, we've got 54 students, and you can see the labs. Their acronyms will be spelled out in a second. But I believe, John, correct me if I'm wrong, but I think we've sent through about 354 students through this project, and they're at various locations with various, some are at NSA, and I really appreciate that. Others are in other industry positions or with other government agencies. The return on investment that we're getting from the technical directors inside NSA is it takes about as much time to work with an intern. So it's not a big load on their normal day-to-day business. But these guys are then also excited because they're working with students. And the students are asking questions that we forgot to ask. How many of us get in our day-to-day realm where we forget to ask some of the tough questions? Yeah, I see some hands and some nods. So the students are stimulating us. And it's really interesting, as many of these organizations have, we have these great rooms at NSA, nothing but whiteboards. And it's cool to get inside one of those rooms. And we've taken on one particular project, the students were working on FIDO, which was a protocol. And we needed some work on that. And so we took what the students did, and we had to brief Congress on that particular aspect. And we took that research into one of our little white rooms, and the guys were just going crazy all over the whiteboards coming up with the briefing we were going to give Congress. And we did give credit to the students. So we were down on the Hill briefing this and said, and oh, by the way, this came from these teams through the INSuRE project. So a lot of aspects that the TDs are getting out of it. The students, we're hearing back from them that it's interesting to actually work with a live NSA technical director, somebody at Pacific Northwest Labs, somebody at Oak Ridge, Tennessee, John Hopkins Applied Physics Lab. Actually working with people who are doing the hard problems today. They're in this interaction through email and through virtual technologies. All the technical directors, their skin to the game. If they're bringing a problem to the table for the students, is their skin in the game is every Friday they have office hours virtually, and the class meets every Friday. And you'll see the amount of universities, and that's nationwide on Friday. That's an interesting opportunity too, learning how do you bring virtually all these universities together and collaborate, because sometimes universities don't like to collaborate. They like to do their own thing. And so bringing many universities together to collaborate has been another learning experience that we've had. Here are the universities that are currently involved. I'll get out of the way so you can see the list. University of Texas pops up, and I think they had some of that stuff on the panel too, so interesting. Just a little note about Mississippi State. One of the serendipities of this program is they did a lot of work on SCADA systems, and one of the semesters the students actually developed a SCADA simulator, and part of the INSuRE project is not losing all that knowledge. And so in our hub there's a simulator that can be reused by anybody who wants to continue doing SCADA work, along with the data to see if you can reproduce that data set and then continue that work. So it's really interesting. Here's all the sponsors. NSA has been in the lead since the beginning. We have a healthy group. You heard Bill Layton mention last time. He's one of our lead technical directors that have been helping out with the students this particular. But you notice Indiana Office of Technology has gotten involved, and we continue to increase the amount of organizations who want to participate because they too don't have the ability to get to some of this research. Cybersecurity fundamentally is unclassified, the science of it. How we apply it gets to be classified, but the fundamental science is not classified, and that's how we can actually do this project. The results, and this is really interesting, and you know, I know that Melissa and I probably thought about this over coffee, but what has come after 5 years of doing this is this persistent, geographically independent virtual network now of all these universities and the professors and the students and the technical directors of this collaborative nature of work on problem sets. And then those problem sets are evolved based upon the work that has been done in the past semesters to evolve that particular problem set, either to say we're done or we need to refine and continue on. The real research challenges that have happened, many students, and when we get people at NSA, we find that they don't have a whole lot of skill sets in doing sustained research virtually, because in the NSA fabric, as well as the other agency fabrics, I can only talk NSA, but my colleagues that I've spoken with have voiced similar aspects, is we don't do anything just in one location. It's all virtual. And that research is ongoing and has a life of its own. So teaching these students how to do that virtual research has shortened the time to work. Because when we hire them in the agency, we find that we have to put them in internship programs to teach them how to do the business. By going through something like INSuRE, that shortens that time frame where they can actually then get to work right away. So this is one of those attributes I think that probably we thought about on the napkin, but has really turned out to be one of a pretty big benefit. Our future with INSuRE, I think, and Melissa, correct me if I'm wrong, but I think we're at that cusp of, we normally have about 7 to 8 universities and about 50 some odd students each semester, but we're brokering on that going larger aspect. There's complications with that. I know it's Davis, right? University of California, Davis is on a quarter system. So how do you synchronize a quarter system with a semester system? That's a challenge because all the students get together and give their midterm reports and their final reports. And so that synchronization is an interesting challenge. How do you make sure that we don't get so many students who are interested that we have overcome our pool of technical directors? Because the technical directors are doing this out of their own personal interest. And when I first pitched this to NSA, our information assurance director basically said, I love the program, don't cost me any money. So that's the way it is with the government. They love to support, but just don't cost me any money. So these are some of the things that we're looking at as coming up with a more collaborative repository to do the data store, sharing of the data. It really has proven this persistent access to knowledge to students and availability. So in summary, what INSuRE has done is proved that we can successfully bring multiple universities together to do these collaborative classes. The students surprise us. Melissa and I were talking about, should we instantiate a multi-university team? And that semester, some folks from Purdue, I think it was Dakota, got together and said, hey, we want to do this multi-university team. Is that okay with you? So the students self-actuated and brought this together. Great stuff there. The agency collaboration, we have the same problem universities do. You know, NSA collaborating with Sandia, with all the other agencies, we just don't have time. So this helped force us into that, and we discovered some great channels of that. So I think I'm going to stop there, because I think I'm getting the 2-year mark, the 2-minute mark. Because I'd like to, as you can see, I'm not very enthusiastic about this program, but would like to open it up for any type of questions that you might have, and Melissa's here to answer stuff that I can't answer. It's really a great program. Looking forward to continuing it, and looking forward to the challenges of continuing it, which are not simple to overcome. But any questions? It's after lunch. Any questions? Answered everything that you could ever know about INSuRE? There's somebody.
So I'm curious how you engage the students and keep your secrets secret. I mean, what's to stop a student from going to work somewhere else, like with a bad guy somewhere?
Yeah, excellent question. And it's one that we internal to NSA had a great conversation about before we really stepped out and got involved. And it's founded on the fact that the science is unclassified, and that we need to utilize as much research as we can. And we've got this great pool of super minds, and we're actually tapping into bachelor degree programs now as well. There's no requirement to be a U.S. citizen to be part of INSuRE. And so it's not lost on us that some of that intellect will probably go places that we prefer it not go. But that's going to happen anyway. Okay? It's not just because INSuRE. These problems are not necessarily specific to the government. They're problems that we are interested in. And so we'd like to pursue those particular problem sets, but it's not unique to the government. And that's how we keep it unclassified. Everything we send out is 100% scrubbed by our folks to make sure it is 100% unclassified, not even for official use only, but generic, unclassified, public releasable problem sets that we go out. Those U.S. citizens who participate, like the one gentleman who we then brought in, cleared, and brought back into NSA, and in fact offered him a job and he's going to come work for us. We take that very seriously as well. It takes about 6 to 8 months to clear someone. And so that process, as most people here have worked with the government know, it takes a long time. So we realize that some of this intellect's going to go to Microsoft, some of it's going to go to Juniper, to Cisco, and we say, outstanding, because that intellect's going to make those products more secure. And remember, rising tide floats all boats. And so we know we're going to float the adversary boat as well, but hopefully we're floating our boat in that process, and being innovative in how we use this technology is kind of what we depend on. Industry would love to have industry involvement. Obviously, in problem definition might be a little bit more difficult because of intellectual property rights. But right now, we've got a wealth of database of very intelligent students and their work product. I don't know if industry would be interested in seeing that if you're looking at hiring someone. So that is where I think the return on investment to industry is if industry, and we're looking at different ways of funding INSuRE for the future, and And so we're looking at different avenues for that to sustain this effort. Obviously, we've got a great pool of research problems, a great pool of data that's already been worked. I'm sure industry, if they had access to that, could say, ooh, that sparks an idea for us to innovate and create a product. Okay, that's another return on investment. As well as, I mean, Hans, we did not get into NSA. He's working for a very wonderful company, and we applaud that because now we know that intellect is helping that company on doing that. So there's lots of different avenues, I think, for industry to get involved, and that's one of the things we're starting to explore in our growth pattern, is how to involve industry in a way that they can benefit and that the students and government can benefit. Great question, thank you. Yes, sir. The security, the question was, what are we doing about the security of the internet, and can these programs address it? I think what this type of program can do is continue the research in the fundamentals of security for the internet. You know, the internet was not designed for security, and so you've got a legacy system that is that rejects the foundations of security in its initial design. And so many of us have legacy systems. It's very hard to go back and patch a legacy system because it'll break it. We heard some of that in the talk of the formal methods. I know of systems that are still running COBOL. How many COBOL programmers are in the room? Okay, see, a couple of us can raise our hands, but not that many of us. So we do have job sustainability, by the way. So very difficult to do that. So I think what we're trying to do is look at the landscape from a security challenge. What security challenge are posed by the internet? What security challenge are posed where we can improve that? And then those turn into research projects at the unclassified level on the foundations of the science of computer security and cybersecurity as it might relate to the internet. And then that work might come inside the agency to further how we look at protecting the internet. Yep. Yep. Right. Yes. Well, and I think the general mentioned that too. It's all about the information. And I think the thinking of having innovative thought on how do we protect the information irrespective of the system it's being shared on. Those innovative thoughts and knowing what we know now about security would be interesting to look at. How do we encapsulate that information, have high assurance on the entity that needs access, whether it be a human or whether it be a process, et cetera. And if you can associate those two together with a high level of assurance, I don't care what network you run it on. Yeah, and so I think those attributes of how do you do that in time. I was talking with somebody over lunch. I don't know if you guys remember Dr. Tao back in the 90s who wrote GemSauce. I don't know if that operating system, I see some smiles. GemSauce was a wonderfully A1 certified formal methods operating system. It would bring an 8088 chip to its knees in operation, but it was used just way ahead of its time. It was a very secure kernel. It was a very small kernel, et cetera. So those thoughts and ideas of how to protect information, how do we do that today? How do we bring those attributes of protecting information in our computing environment and maybe take a step back and say, why are we protecting the network? What are we doing to protect the information and to protect those who gain access to that information versus the network? Yeah, great question. Great, thank you very much. It's really great to work with Purdue.